A pleasant day to each and everyone. I am Sheena Hemantiza, a BA Ed 2A student at Eastern Visayas State University, Burawin campus. Now, I am here to give understanding about the minerals of the earth. The earth is made of rocks which are turned of minerals. In this part of the course, we'll learn how to identify common minerals and rocks. In order for something to be classified as a mineral, it must meet five criteria. Minerals are naturally occurring, inorganic, have known chemical compositions, have definite physical properties, and are solid. They are usually crystalline. Now, let us move to the classification of minerals. Minerals are classified based on chemical composition and crystal structure. Minerals are made of different ions bonded together. Ions are charged atoms and canions are passively charged, whereas the anions are negatively charged. Minerals are made mainly of the ions. Crystal structure depends on the sizes of charges on ions. Most common mineral group is the silicates. All the silicate minerals contain silicon and oxygen. Mafic silicate minerals contain iron or magnesium and dark in color. Examples are olivine, proximine, amphibole, and biotite mica. Felsic silicates don't contain magnesium or iron and are light in color. Examples are feldspar, quartz, clay minerals, and muscovite mica.
Mafic silicate and felsic silicate.
Silicate mineral structures. Basic building blocks: silica tetrahedron is a silicon ion bonded to four oxygen ions. Silicon is positively charged in positive 4 and oxygen is negatively charged in negative 2. And the net charge on the tetrahedron is negative 4. Because the entire tetrahedron is negatively charged, it is attracted to canions.
Silica tetrahedron.
Next is the isolated tetrahedron. Canions serve as links between tetrahedra. No sharing of oxygens. Examples are olivine and garnet, which also happen to be mafic silicates. Single-chain silicates. Adjacent tetrahedra form a chain by sharing two of their oxygens with neighboring tetrahedra. Example is proxenes, which also happen to be mafic silicates. Double-chain silicates. Two chains can link up by sharing oxygens. Example is amphiboles, which are mafic silicates too. Sheet silicates. Sheet silicates are formed when each tetrahedron shares three of its oxygens with its neighbors. Examples are micas, biotite, which is mafic, and muscovite, a non-mafic, and clay minerals, which are in non-mafic silicates. Next, framework silicates. Every oxygen in each tetrahedron is shared to form 3D framework. Examples are feldspar, quartz, which are also non-mafic.
Common non-silicate minerals: fluorite, calcite, dolomite, gypsum, galena, pyrite, halite. Common non-silicate mineral groups.
How to identify minerals, physical properties. Geologists determine the identification of an unknown mineral by describing its physical properties. They then use a reference book to find out what mineral has those properties. We will learn to describe the physical properties. First is the habit. It refers to the overall shape of the mineral. Scientists use terms like a quant. The three dimensions of the mineral have about the same length, like a cube or sphere. Elongate, one direction is long but other two are short like a pencil. Or platy, one dimension is short, other two are long like a sheet of paper. Isolated tetrahedron and framework silicate mineral tend to be equant in habit. Chain silicates to be elongate, sheet silicates are too platy. Number 2, the luster. It refers to the light reflected of the mineral and its overall quality. Minerals can be learned glassy, opaque, transparent, shiny, or most commonly metallic and non-metallic. One of the first dimensions is geologists must make is whether to the mineral in metallic or non-metallic. The cleavage refers to very smooth, flat, shiny breakage surfaces. These special breakage surfaces correspond to zones of weak bonding in this crystal structure. To describe cleavage, one must determine the number of unique cleavage planes and their angle with respect to each other. Example, salt breaks into cubes with cleavage in 3 directions, all the 90 degrees. Hardness refers to the scratchability of resistance to being scratched. Harder minerals will scratch softer minerals. Geologists rank minerals according to hardness using the Mohs scale. Below is the Mohs hardness scale. Color varies in many minerals. Some minerals come in just one color. Others are many colors, many varieties. Streak refers to color or mark left by rubbing mineral against a streak plate. Streak does not vary even color does.